Hello, welcome back. So let me pick up from where we left off in our last segment. So I just, found I covered, the first um, scenario where, correlation is -1, and then if I replicate it for the case of uh, correlation of 0 and 0.2, 0.5, and 1. These are the minimum variance, conditions, weight and, um, the portfolio return and standard deviation and so on. And if you compare it with the slide, the PowerPoint, you might find there's a slight discrepancy, why? A slight discrepancy is mainly due to the rounding, because I'm using exactly the computed value for, standard deviation of stock portfolio and standard deviation of the bond portfolio. But in the slide, they use just completely, rounded numbers. So for stock portfolio standard deviation, they use 19%. For bond portfolio, they use 8%. So that rounding results in a discrepancy in the weights, right? So then if the weights are now different, then it's going to be all different. But this discrepancy is relatively minimal. Now, so that was what was supposed to be. So highlight, don't forget. So then, what are the implications of, these different, correlations? What are the implications to the frontier, or it's called also investment opportunity sets. It's actually the frontier of investment opportunity sets. So let me switch to again. I'll have to cut this off and switch to no, not camera, but application. Okay, there you go, and you should be seeing it just about now. Okay, let's see. Yeah, you're watching it, right? So when we had those different, yeah, here it is. This is the shape of the investment opportunity set for the front investment opportunity front, right? And our so when the correlation is 0, when the correlation is -1, the correlation is 0.2, and correlation 0.2 is this, gray convex curve, whereas correlation of 0 is this thick blue convex curve. And so this is our scenario, and if there is no correlation whatsoever, it is truly well diversified. And when there is no correlation is 0, you have really the minimum variance, right? Minimum variance, because as I said. And then when the correlation is 1, they move in tandem. So there's no diversification, right? There's no the effect of diversification, right? It's just a straight line. And when the correlation is -1, it's going in completely opposite direction, right? One one will represent stock, the other one will represent bond, right? So they are completely in opposite direction. Okay, and of course we already understand what is the minimum variance. You know, this convex curvature of this investment opportunity frontier is convex, of course, and then this is the minimum variance point. Where the and then the bond, actually, you know, bonds. Remember when we you know, constructed this risky portfolio, right? And we benefit. You know, I mean, you might think, you know, oh, if we just, you know, put 100% into a bond, wouldn't we have, because the bonds have, you know, a low risk. No, bonds have lower risk than the stocks, but that doesn't mean, you know, completely no risk. Only the treasury is risk-free, and only treasury has zero variance. But, you know, I mean, even the treasury return has some sort of variance, but, you know, very small. But risky bonds, you know, other than treasury, risky bonds would have some variance. So, and the stock would have so much variance. Look at the stock's return, you know, high return, but also high variance. Whereas, you know, bond has low return, lower variance than stock. So when we construct this risky portfolio, right, we can even reach the minimum variance, which is even lower than the bond's variance. And of course, the you know, this frontier, obviously the frontier is, you know, the better, the more preferred, the more northwest the frontier is situated or located, right? There can be, in other words, there can be, you know, a frontier like this, a frontier like this, a frontier like this, and the further it moves, you know, in other words, I want to draw that, you know, I won't make it messy. The more northwesterly located frontiers are preferred, because those frontiers would have higher expected return for the same variance, or, you know, for the same return, they have lower variance, right? There's a picture of that somewhere. Yeah, something like this. You know, as you go, A frontier A is preferred only in terms of, you know, that's not. As you move this way, you know, you have higher for the same. Look at this point, higher return for the same variance. You know, for example, better than this one, right? That includes, you know, this point. I mean, without further explanation, you would understand what it means, you know. Now, think about it. For the same variance, the more northwesterly, the return is higher, and for the same return, the more northwesterly, the variance is smaller. So it's preferred as the frontier moves to the northwest. Now, and we did this, and basically, you know, now we bring back the concept of capital allocation line, and we know the slope of capital allocation line is the Sharpe ratio. So if this is our frontier, right? Investment opportunity set, frontier of investment opportunity sets. And if we draw a capital allocation line, which is the slope, of course, this slope, this line passes through the minimum variance point. But this is not the most efficient one because we can do better for this variance. We can do better, right? For this variance, we can do better in terms of return, right? In terms of return. And all these returns are not the most efficient returns because on every point, right, we have better investment opportunity sets, right? For example, if this is the 10% is the standard deviation, right? And along this minimum variance CAL, right? Return would be like 6%. But our investment opportunity frontier offers like 7% return. So we can do better. That's the reason why we don't pick this minimum variance point, right? The best thing, the slope of this curve is actually this green line. This green straight line is the slope, actually the slope of this investment opportunity frontier, right? And slope is basically a straight line that is tangent, right? That is tangent to the curve. So this is a maximum Sharpe ratio we can get, and this capital allocation line is this is not 0, this is O for optimal portfolio, optimal capital allocation line. Okay, and we all know that CAL A dominates CAL mean because of that was what I was talking about. For the same variance, the higher return will dominate the lower return, or for the same return, lower variance will dominate higher variance, right? Okay, so then our question is, so how do we find the weight then? How do we find the weight for that, maximum Sharpe ratio, or how do we find the weight for that optimal capital allocation line? So we know the formula for minimum variance weight, right? And the formula for Sharpe ratio maximizing weight, right, is like this. Weight of bond will be like this, then the weight of the stock will be 1 minus weight of bond. And then it's basically this structure simply adjusted by risk premium, right? Simply adjusted by risk premium, right? For stock, the risk premium on the bond. For term, risk premium on the stock. It's kind of like reversed, isn't it, right? For stock, the coefficient is the risk premium on the bond. For bond is the risk premium on the stock, right? And then for the product term, in the denominator, because it is 2, right? 2 times the it's risk premium on the bond plus risk premium on the stock. And if you do that, we calculate this point. And so here, so CAL O optimal portfolio capital allocation line. According to that, if we calculate it, our return on the optimal portfolio will be 7.16, and standard deviation will be 10.15. And the idea is, we all understand that and when we get the optimal wait for optimal portfolio, or wait for our optimal portfolio. I wish I could draw it like let me use something like this. I'm afraid to draw anything. If it is like, let's say it is like this, right? If it is like this, let's say it is like this. So, and then, when we have optimal risky portfolio, then we add risk-free assets to make it make it complete portfolio, and our complete portfolio will have the same expected return and same standard deviation as the risky portfolio, because it has the same Sharpe ratio. In other words, adding risk-free assets do not add anymore to the risk, and it only adds the lower bound. It adds the lower bound because that's the risk-free return. It adds the lower bound to our portfolio. And the Sharpe ratio is the same because, think about it, Sharpe ratio, it doesn't increase or decrease the Sharpe ratio of the optimal portfolio. And we already know this from the previous chapter, because the I forgot to put the weight here, but let me do this. The only thing we need is so if we think about what it does to the risk of the complete portfolio, it adds nothing. It doesn't add any risk, because it's risk free. So the weight of the complete since the standard deviation of the complete portfolio is the same thing as the standard deviation of the optimal risky portfolio, right? The Sharpe ratio is the same, right? And you want to maximize the Sharpe ratio. The maximum possible Sharpe ratio given the investment opportunity frontier is achieved. Of course, if we can make another mix or another combination, And if this frontier is moving to the northwest, then what happens? The Sharpe ratio will go up. And the higher the Sharpe ratio, the better it is, right? That's the idea. So then, once we have found the weight and our weight came out as what was the weight that we calculated? When it is 0.2, the weight was our optimal weight was 0.923, which is like which is on stock, right? 0.9%. And 1 minus, let me, weight of the stock is, okay, I get it. And from, we, from complete portfolio, right, we found Y to be, 55%. So we put 55% into risky portfolio, right? To optimal risky portfolio, right? And then 1 minus Y, which is 55%. I mean, 45% goes to risk-free assets. It's so hard to write it. Oh, come on. Okay. And then so from 55% times weight of stock, and weight of stock was 0.09 something, I guess. That was what? 932, right? And the bonds, or basically, that comes from 55% times 1 minus that, 1 minus weight of, which is weight of bond. 1 minus rate of stock. And it comes to, just wait a moment. And which comes to, right, 31. Percent. Let me quickly check that. Because I'm kind of this is a little okay. Was this not the same example? I don't. Was kind of. So I'm going to have to run the number again because this doesn't seem to give you the. I'll have to check the number again. But the may have come from a different example. Why is it? Maybe the the correlation coefficient wasn't 0.2. Maybe it wasn't the same continuing example. Oh, here the weight is kind of different. No wonder. Oh yeah. I mean, it wasn't the same example, as I said, because they used slightly not the same thing. That was 0.568, 0.432. That's the weight in stock. And then, anyway, so the example this came from a slightly different example, so that's why. So that explains, the composition, right? How the weight by, how the complete portfolio is composed of, right? And then efficient frontier of risky assets. We need to, which one is then the efficient one? I mean, opportunity, investment opportunity sets, we know the northwest, the more to the northwest it goes, the better it is, more preferred, right? But of all of them, which one is the best? So efficient frontier risky asset of risky assets graphs representing it's a graph representing several portfolios that maximizes the expected return at each level of portfolio risk. I told you, holding, in other words, given a standard deviation level, there are multiple choices of expected returns, multiple, and of course, for a given risk level, the higher the return, the better it is, or vice versa. For a given level of expected return, the lower the risk, the better it is. Right? So that's basically what it is saying. And so maximize risk premium for any the efficient one is the one that maximizes the premium for any level of risk. Minimize the one that minimizes the risk for any level of premium. To maximize, in other words, the whole point is we want to maximize the Sharpe ratio, right? Maximize the Sharpe ratio for any risk or risk premium. Okay, one of the two ways to maximize the Sharpe ratio, one of the two ways, right? Either to maximize the Sharpe ratio, either one of those. Ah, yeah. So max the Sharpe ratio of complete portfolio. So choosing the optimal risky portfolio is very, critical because, the Sharpe ratio of the optimal risky portfolio, determines the Sharpe ratio of the complete. Optimal portfolio CAL is tangent to efficient frontier. The preferred, the higher the, the more northwesterly the efficient frontier moves, will result in a higher CAL and higher Sharpe ratio. Preferred complete portfolio and separation property. Separation property implies portfolio choice separated into two tasks. One, determination of optimal risky portfolio is a purely technical problem by analyst, right? And then personal choice of best mix of risky portfolio and risk-free assets would be, another thing, and as an investor, right? I mean, as an analyst or as a portfolio manager, determining which is your optimal risky portfolio is technical, really. Whatever is increasing your Sharpe ratio, but to maximize the Sharpe ratio, you have two, strategies for that. But then, some people, as individual investors, it's not always the same thing. I mean, you may disagree with the fund manager. You may be more, risk taker. Then you push the can push the frontier. You choose the frontier that is more towards, to the southeast. or not necessarily southeast, but something that has higher risk and higher, for example, this is another another discussion, but suppose you want this return, but you are only your investment opportunity set is like this. This is higher, it's more north, but it is not west. It's not to the west, right? And if you're a risk-averse investor, your selection of investment opportunities would be like this, right? Obviously, you have lower risk, but return, and you are more to the west, but you are not north, right? But these differences can be individual differences, right? As individual investors with different risk tolerance. Okay, now this is another another discussion actually, and we will we will have to talk about in the next video because we have pretty run out of time. Right. So that's it for now, and I will see you guys in the next video. Stop recording.